Now that we've learned how to create our own classes in C#, we've come to an important point in the course where we need to learn the difference between value types and reference types. C# has two main types. There's value types and there's reference types. Value types are all of the primitive types that we've learned about so far. Things like integers and longs and shorts and decimals and chars and booleans and so on. And there's also a thing called struct, which we haven't covered yet, but we will cover later on in the course. Anyway, those are the value types. Reference types are classes, arrays, and a couple of things called delegates and interfaces, which again, we haven't yet covered, but we will cover later. So why is there this difference and what's so important about it? The main difference between value types and reference types is how they are handled in memory. And the best way to learn this is to see an example. So we're going to compare the value types with the reference types. Now, for a value type, let's take a really simple example. Let's suppose I have a variable I, and I declare it as an integer, and I set its value to 5. Now, when I do that, the C# compiler goes out in memory and makes a little box called I, and it puts the value 5 in it. If I declare another variable called j, and I set it equal to I, then the compiler sets aside another little box, and this little box is called j, and it also gets the same value as I, which is 5. Now, the important thing to remember here is that j is a copy of the value that's stored in I right now. So if I go back and change the value of I to 3, the value of I gets changed, but the value of j does not get changed because these are different memory locations. Now let's compare that with how reference types works. So suppose I made a class called point, and inside my point class I had two integer member variables, x and y, which represent the coordinates of the point. To create a new point, I would declare a point class variable named p1, and I would use the new operator to create a new instance of the point object. Then I could do something. Now, since these are public member variables, I could say p1.x and p1.y are equal to 10. Let's watch what happens in memory. Well, in memory, that little location called p1 for the variable gets created, but what also gets created is a set of bytes somewhere else in memory that actually hold the member variables. And P1 is not actually containing that data. It contains a reference to that data. There's this little reference that goes out into memory and knows where x and y are stored. So let's suppose I made another variable called point P2. And rather than doing new point, I say point P2 is equal to P1. Well, that creates a little local variable there called P2. But watch what happens. The reference gets set to the same reference as P1. They're sharing the same reference to the same location in memory because I didn't make a new instance of point. I simply set P2 to be equal to P1. And when you do that with a reference type, you're sharing the same reference. What does that mean? Well, if I then do something like this, where I set P1.x is equal to 20, it changes for the both of them. So even though I didn't do anything to mess with P2, P2.x is now having the value of 20 the same way that P1.x is. This is an interesting side effect of how reference types works, and you need to watch out for it in your code. Let's go over to the code environment and take a deeper look at this. So I'm here in my val and ref types example file, and I've got the program.cs file open, and I've got my snippets here. So what I'm going to do is, back here in my code, I'm going to put some code in here that exercises both the reference and value types that we saw earlier. So let's go back over here. What I'm going to do is copy this line right here, which is the point definition, put it into my file over here. I'll just put it right in front of the program class. I'll save that. And then I'm going to copy over this function right here called testfunc1. And this is the first test that we'll run. So I'm going to copy that. I'm going to put that in my program down here. So now let's copy over some of the logic to see what's happening. Go back to my snippets. I'm going to scroll down a little bit. Copy these few lines right here, starting with this variable and down through this right line. I'm going to copy that and paste it into my main. So let's take a look at the code that we have here. We'll use point a little bit. I just want to make sure we had it in place. For now, we're just going to concentrate on this code right here. In my main function, I've got a variable called I, and I'm setting it to be the value of 10. And then I call this function testfunc1 with the I variables. Let's scroll down and see what testfunc1 is. You can see it takes an integer argument, and the first thing it does is it adds 10 to the argument that's passed into the function. when this console.writeLine gets executed, it's going to write out the value of whatever arg1 is. And then when the function completes and goes back up, we're going to write out whatever the value of I is. Go ahead and place your wagers and let's see what happens. Build this and we're going to run it. So you can see that what happened was we passed the 10 into the function and arg1 was set to 10, but then we added 10 to it, so now it's 20. But when we come back out of the function, the original variable I is unchanged. It's still 10, even though we added 10 to it inside the function. So let's go back and take a look at the code. The reason why this works is because for primitive value types, like integers, when you call a function and you pass in the value as an argument to the function, it is passed as a copy. When you pass value types, you pass a copy of their original values. So even though we changed the value in here on line 29, since we're passing in a copy of the local I variable from main, we're not actually changing the I variable. We're only changing the local copy that testfunc1 is working with. Let's go back and copy in the rest of our code. And I'm going to copy in these lines here, put them in my main function. And now I need to copy over my other test function, which is this one right over here. And I'll put that down below here. And now we'll save everything. Now let's go ahead and run our next test. And for this, I'm going to get rid of these lines of code because we don't need them. So here I'm using the point class, which I've defined up above my main. Here's the point class. It's got an x and a y value. So on line 19, I'm creating a new point, and I set p.x and p.y to both be 10. Then here on line 22, I write out the value of the x property. Then I call this testfunc2 with p, that's the point, and then I write out p.x again. Let's see what testfunc2 is doing. Well, testfunc2 takes a point argument, as you would expect. It writes out the value of pt.x. Then it adds 10 to the value, and then it writes out pt.x again. So we're going to write out four things here. We're going to write out the value of the points x field, both inside the test function and outside the test function. So let's go ahead and compile this and run it. And you can see that before we call the function, the value of p.x is 10. Then we go into the function, and pt, that's the local variable inside that function, is 10. Then we add 10 to it, which gives us the value of 20. And we write that out. So inside the function, pt.x has been changed to 20. Then we exit the function and go back into main, and you can see that the value of p.x has been changed to 20. So in this case, the value was changed. Let's go see why. Remember that point is a class, and the class was one of those things that we looked at earlier was a reference type. So when you make a new point like this here on line 19, and then you pass it into a function, you're not passing a copy. You're now passing it by reference. And because testfunc2 has a reference to the original point, if you change it inside the function, it will change outside the function as well. This is the fundamental difference between value types and reference types, and it's something you'll come across in C# on a regular basis.